Okay, so let me tell you some other things that are important. Um, have you worked on problems related to integer part, fractional part, or something like that?
Maybe. I'm not sure exactly what that's.
Okay, so we have one important idea. I can say 90% of the problems that we have fractional part or integer part, we should use that. Do you know it is what?
Um, them added together is equal to the integer.
Yes, we say x is k plus r. K, for example, is integer part. R is fractional part. And what's the condition for R?
Um, it's less than 1.
And
It's positive.
greater than equals 0, right? So fractional part of 2.7 is what?
0.7.
Fractional part of 3 is what?
0.
Fractional part of negative 5.4 is what?
0.6.
Exactly. You can say negative 5.4. Floor of that is what? Integer part of that is what?
The floor is -6.
Yes, negative 6 plus 0.6, right? So for all numbers, it is not important that the number is negative or positive. We have this one. And this is so much important. At first, we think that, okay, it's an obvious thing, but we can solve hard problems with only this idea. So let me check first a small, an easy problem. We will solve first a PMO problem. It's for Philippine. Then I will tell you AIME problem because we can solve them with same idea, similar idea, but PMO problem is a bit easier. So let me just check that can you apply this or not. So the problem is this, and let me explain for you first. It says floor is this. If an times floor of an is this one, find the value of this. Calculating this sigma takes time and you can do it as homework. I want that you find only an equals what, okay? Then you can do this one as homework one, the calculation is what. So focus on finding an only in terms of n, okay? Try first on your own.
I don't know how to do this.
Okay, an is what?
I can write an as floor an plus decimal.
No. Close form of an. Means
No.
an, for example, equals 3n plus 4 something. Only in terms of n, not ai. Okay.
I couldn't solve it.
One hint.
Yeah.
Use exactly the previous idea I told you because we want to also apply that on AIME problem. I said what? When you want to find an, I should divide it to what?
Fractional part plus
Yes, k plus r. And the condition was what?
R is between 0 and 1.
Yes. Greater than equals 0, strictly less than 1. Okay, it's important to pay attention to this word. So can you tell me floor of an will be what in terms of k and r?
Just k.
And an is what?
K plus r.
So as a hint, you should find k first. Then after finding k, you can find r. One more hint or that's enough? The next step is solution. If I want to tell you one more. One.
Yeah.
One more hint or one. Wanna keep trying? Hint. Okay, so k times k plus r. Can you tell me it is at greater than equal what less than what? Something is squared, something is squared.
K squared.
Exactly, and
K plus 1 squared.
yes. So k times k plus r is this number, right? So 49 to the n plus 2n plus 1 is greater than equal k squared less than k plus 1 squared, right?
Yeah.
So now we can say our claim is k equals what in terms of n?
K equals what is this? This is inequality. Square root of 49 to the n plus 2n plus 1.
K is integer, okay?
So k is the floor. Square root of the
Yes, but I want that you tell me k is what exactly in terms of n without floor. Calculate floor of that, okay? You can calculate, it's not hard.
The floor of the expression in the middle.
Exactly. Floor of a square root of expression in the middle, okay?
Is it just like 7 to the n?
Exactly, 7 to the n. Because look, when we consider, do you agree in for large n, these numbers are so much smaller than 49 to the n.
Yeah.
Okay, so we can approximately say that this one will be 49 to the n. So our claim is 7 to the n, but we should prove it, okay? So let's prove it.
Okay.
7 to the n, and we agree only one case satisfies this, right? One case satisfies this inequality because this number is between two consecutive perfect squares, right?
Uh-huh.
Okay, so 7 to the n, if you prove that 7 to the n works, it means that for the only number that works, k has to be equal to 7 to the n. So 7 to the 2n, 49 to the n plus 2n plus 1. This one, it is equivalent that 2n plus 1 greater than equal 0, which is correct, right?
Yeah.
Now for next part. 49 to the n plus 2n plus 1 is less than 7 to the n plus 1 whole squared. So it will be 49 to the n plus 2 times 7 to the n plus 1. You can cancel these two parts. And then you can cancel 1. You can cancel, it means you subtract 1. Here you divide both sides by 2. And then we should prove that n is less than 7 to the n. For n1 it is correct, and in each step this one will be plus 1, this one will be multiplied by 7, right? So always this one will be greater than this one. So for 7 to the n, we have this inequality will be satisfied, right?
Uh-huh.
Okay, now we found that an equals 7 to the n plus r, which r is from 0 to 1. Okay, now calculate r in terms of n. This part is easier than previous part. Try to calculate r in terms of n.
2n plus 1 over 7 to the n.
Can you say it again?
2n plus 1 divided by 7 to the power of n.
2n plus 1 over 7 divided by 7 to the power of n. Yes, and this one you only replaced this in this inequality, right? And you replace
Yeah.
k with 7 to the n.
7 to
Okay.
the n.
Yes, your answer is correct. Want to check that or that's okay?
That's fine.
Okay. Now we solve this one, and then for as homework 1, let me draw a rectangle around that. As homework 1, try to solve this problem, okay? Completely. Okay, because the rest is not related to thing we want, only related to calculation, and you can solve it. Now let's solve AIME problem. The important one part was AIME problem. I think it is for 2022. I will tell you exactly here. 2020, I think it was. Oh, let me copy. Okay. So the problem is this. Have you seen this problem before?
No, I've seen a different like floor problem with the AIME, but yeah.
Okay. So try this problem first on your own, okay?
Okay.
It has similar idea, okay? Like previous problem, it doesn't have any new idea, but related to problem solving, how to apply that. Okay, try.
I don't really know how to do this.
Okay, one hint.
Yeah.
Okay, I said in generally, AIME, AMC, use some IMO. When you see a problem and it's hard and nothing comes to your mind, you should do what?
Just come up with some like small examples.
Exactly. We should use the small examples, but from different aspects, we can reach different small examples, considering small examples. Can you guess that here we should use a small example on what?
Uh, on f of like something equals 17.
So on F, can you explain more? So for example, first case that we should check is what?
Like 0 no.
0 means instead of 17, 0.
Um,
You can check that the small example, but I don't think it works. So if you want to use a small example on F, then we should check what first?
I don't know. I'm not sure what's
Our
to do.
problem here, the difficulty here is we have 3 Fs, right?
Yeah.
These
Just do
3
with
Fs makes the
with it.
problem hard. So we should do what first?
Do it with like 2f or like 1f.
Oh yes, 1F first, right? So we should solve this problem for 1F first. So pay attention when nothing comes to your mind, also for homework. When you want to solve a problem at home, if you couldn't solve, check a small example from different aspects here. 1F, consider f of x equals 17 and try to solve it for this case. Okay, again, x is from 0 to 20, 20. Try to see for how many x's f of x equals 17. Okay.
Is it 2003?
2003. Let's check. 2003. Let's move it here. Okay. 2003. So here again, we want to use same thing. Suppose x is k plus r. Okay. And r is from 0 to 1. So can you tell me f of x is what in terms of, it is x times fractional part of x. It is what in terms of k and r?
It's k times r.
K plus r times r, right?
Yeah.
Okay. And we want that this one should be equal to what? 17, right?
Wait.
So it is
Oh,
r
I did this. Yeah.
it is r squared plus rk or kr minus 17 equals 0, right? So can you tell me
Yeah.
r is what in terms of k?
1 second. Wait, how do you isolate the r here? What?
Do you agree it's a quadratic equation in terms of r?
Oh, so just quadratic formula.
Yes.
Negative k plus minus square root of k squared minus 4 plus 4 times negative 17 over 2.
Yeah, so it will be k squared plus what?
68.
Over what?
2.
We should select plus or minus.
Plus.
Y plus.
Because if they're both minus, then it's just a negative number.
Exactly. It should be at least 0. And we know k is at least what? In this problem.
Is that
K is at least
k
what?
is between 0, at least 0.
Yes, because k is at least 0. So if you select minus, this part will be negative, right? So
Yeah.
we can say r is negative k plus square root of k squared plus 68 over 2, right?
Mm-hmm.
And now we want to check, it's greater than equal 0. We know r should be greater than equal 0 and less than 1, right?
Mm-hmm.
We want to see, is it always correct or not? Okay, so for left hand side, is this inequality always correct or not? If it is correct, prove it. Prove this part first on your own.
I mean, this is always greater than 0. That's true.
Greater than equal 0. Why always greater than equal 0?
Because the over 2 doesn't matter, and then it's just like,
It,
because in the bracket it's k squared plus square root of 60, k squared plus
exactly.
68.
And you
can
can write it like this. It's obviously correct. What about less than 1? Try to simplify it and see the last term here. The last term, it was 68 greater than equal 0, which was correct. Simplify this and see the last term that is obvious is what?
I got k is greater than 16.
K is greater than 16. Okay, let's check. Here it's equivalent that if we multiply by 2, then add k, it will be k plus 2, greater than k squared plus 68. So if we raise to the power of 2, it will be, because both sides are positive, because k is at least 0. K squared plus 4k plus 4, right?
Yeah.
So it is equivalent that 4k greater than what? 64. So k greater than what? 16. Okay, or k greater than equals 17, right?
Yeah.
And we know, we know for k greater than equals 17, always we have a good answer, right? R will be good. And exactly one R is good. R will be determined by k, right? So now last session I told you an idea. It was drawing the graph, right?
Yeah.
Okay, so here we can say what? You can say, okay, from 17 to 18, there exists exactly one good number, right?
Yeah.
From 18 to 19, exactly one good number, because k is good, then you can find a unique R. Up to 2019 to 2020, right? A good number. So for each of them, you can say 17, 18 to 2019. It will be 2019 minus 16, which is 2003, right?
Yeah.
And then we want to generalize this approach for f of x. What was your solution for 2003?
I read the problem. Like I thought it was floor of x times I thought it was floor of x times what's it called? A decimal of x.
Fractional part, this one?
Yeah. Instead of but then it's the whole, like it's the number itself, not the floor.
So your solution is not correct?
No, because I thought I misread the problem.
Okay. So now we prove that there exists a good number. For also AMC problem, you should use exactly same thing. I know some AMC problems that when you want to solve, you should find R, you should find quadratic formula, and then you should check this inequality. But in AMC problems, when you check this inequality, the problem will be solved. This problem is a bit harder. So we solve for 1f 2003. Next part, f of x equals 17 again. And do the same thing and see for this one how many numbers are there. Okay?
Is it like um
Can you say it again?
I don't know, I'm trying to think. It's like I need fx to equal some of these like integer, some not these integers, some of these like solutions that are between that are on this number line.
There are
And then
some of
there's
them. Can you tell me only one of them? I think is integer. When r is 0, k equals
not integer,
68.
I didn't
Oh
I
no,
didn't mean
yes, not
integers.
integer because 68 greater than equals 0. None of them is
Yeah,
integer,
none of
right?
them are integers. It's just like
But you should use exactly same approach.
how do I approach it? Because there's all these different. It's like each one has less solutions.
So let me one thing.
Well, I kind of get it, but I kind of don't. It's like,
Okay, wanna keep trying?
well, no, but it's like 17. The one between 17 and 18 would have.
Exactly. How many numbers can reach this? You should calculate for each of them how many numbers can reach each of them. And if you find one of them, then you can conclude. You can
Because they should just be decreasing by one.
somehow like that. So try to see this one is what, this one is what, this one is what. Calculate one of them first. Or if you can find, for example, generalize it. For example, suppose it is a, f of x should be a, right? And a
Yeah.
is at least 17 and strictly greater than 17, right? Because they cannot be integer. And less than what? 2020, right?
Yeah.
Okay. So for this a, f of x, if you use exactly same approach, you can find how many answers do we have in terms of a. Okay? Exactly, you should use same approach. So try. So let me review this part again. Look, here it is the number. A can be this one, can be this one. We know f of x is this one, then f of x will be 17. A is from 17 to 2020. Try to find for f of x equals a. How many answers are there? Exactly, use same approach and find your answer in terms of a. Try.
So I got A is less than K plus 1.
It is what?
I just got A is less than K plus 1.
A is less than K plus 1. Or it's better to say K is greater than what? Because you want to find how many K's are there or how many R's are there, right?
So K is greater than or equal to A minus 1.
So, for example, for this part, if A is from 17 to 18, how many good K's are there? We know K is at least 0 and strictly less than 2020, right? Or we can say at most 2019. Why 2020 doesn't work for K?
Because then the decimal part would be 0.
Exactly, because the fraction part is 0. So K is from here to here. So you found K in terms of A. And inequality, for example, K greater than what? So try to see, for example, for this one, the answer is what?
From 17 to 2019.
So it's what? For first question mark is what?
2003.
2003.
Yeah.
What about next one?
2002.
Yes. What about last one?
1.
1. Exactly. I think it is this because it should be started from 1. So let's check together quickly. F of x again is x times this part. It is k plus r times what? Times r equals a, right? So r squared plus kr minus a equals 0. So r is negative k plus minus square root of k squared plus 4a over 2, right? Again, we should select plus because it should be greater than or equal 0, k squared plus 4a over 2, greater than or equal 0, less than 1. If we check this one, we can multiply by 2, then k is less than or equal to k squared plus 4a. And we know a is greater than 17, right?
Yeah.
So here k squared plus 4a obviously is correct because if you raise to the power of 2 k squared plus 4a greater than 0. For this one, you can say k squared plus. If we multiply by 2, add by k, and then raise to the power of 2, it will be k squared plus 4a less than 2 plus k squared. K plus 2 squared is k squared plus 4k plus 4. So we can cancel this. We can divide both sides by 4. So k should be greater than a minus 1. So from first one, that this one is here, k should be greater than this minus 1 here. So k can be from 16, right? For this one. At least 16. K can be at least 16 to... Oh, sorry. K should be at least 17 because K is strictly greater than this number that from 16 to 17. So K is at least 17 to 2019. Again, it will be 2003. For next one, K should be at least 18 less than 2009, right? And you can continue like this, right? And for this one, K is at most 2000. At least 2019 and most 2019, so it will be 1. So can you tell me here the answer will be what, 1 to 2003?
Just n times n plus 1 over 2. So
We don't need to calculate, only 2003 times 2004 over 2, okay?
Yeah.
Last part is important for calculating f of, now apply f of x equals 17. Try this part.
Not sure what to do here. I don't know what the solutions are.
Okay, so let's use our previous number line that we had. You should use exactly the same thing. Here we don't need to do any new thing. Let me explain for you here. So for reaching this one, you said 2003 numbers, right?
Yeah.
Okay. So can you tell me these 2003 numbers that we want to reach this? Do you agree one of them is here, one of them is here, one of them is here, right?
Why are they spread out?
Because here you said k is from a minus 1. So for example, for this one, 17. K is greater than 16, right?
Okay.
And less than what? Less than or equal 2019, right? So suppose, for example, a is from 17 to 18. I want to only consider this one. So do you agree k will be at least 17 and at most 2019?
Yeah.
So do you agree for each k we have a good number?
Yeah.
So for k17 it means this black, for k18 this black, for k2019 this black. This one goes here, after taking 1f goes here, and this one goes here, right?
Yeah.
And this one goes what? This one goes to 17. Look, for example, pink numbers. These pink numbers, by one step they go to 17, right? And these black numbers go to this pink point. Agree?
Yeah.
Now let's consider green points. So you should see, for example, for this one, which numbers reach this one, and you've checked that in previous case. Also for this one, you should say, okay, which numbers go to this, and then which numbers go to this. Understood? You should do what? It's a bit hard. You should think a little about this, but understood a bit that you should do what?
Kinda.
Okay, so try to see. Okay, so these pinks are the things that we reach in one step. Then you found for each pink in previous part that how many blacks are there. Now you should focus on each black. Okay, so try first on your own.
I still don't really get it. It's too difficult. It's just like they all have more solutions. God, I don't know what's going on here.
Can you speak a bit louder? Your sound is too much low.
Oh, yeah, I don't really know what to do here.
Okay. So for this black one, do you agree for this pink one, you said there are 23 numbers that can reach this, right?
Yeah.
So now do you agree we should find this black one? Because if something goes here, then f of this number is 2070. And these numbers are the things that we want, right?
Yeah.
Okay. So can you tell me, do you agree this black is exactly similar to this pink? For
What do you
this
mean
pink,
exactly
you said,
similar?
because it is between 17 and 18, there are 23 numbers that we can reach, right?
23?
2003.
Oh.
Agreed? For this pink,
Yeah.
how many numbers can reach this pink by 1F?
2003, remember?
2003. So do you agree for this black also because it is from 17 to 18, there are 2003?
Okay.
Okay, so finish. So for this one, 2003. What about this one?
2002?
Yes. And for this one,
1?
1. So 1 to 2003, these numbers, some of them, if we add all these numbers, they reach to this black by 1F. By 1F reach to this pink. By 1F they reach to 17. So these numbers are good, right? So 2003 plus 2002 plus 1. All these numbers were good because of these pink points, right?
Yeah.
Okay, so calculate the rest. Calculate final answer, okay? The rest is so much easy. And the problem says calculate the answer mod 1000. Okay, so try.
Wait, but there's 2003 pink ones?
Yes, and they are different. I've calculated one of them for you. Then rest are similar, not exactly equal, but similar. So try the rest. Okay, for this pink one, these numbers. Okay. Now calculate next pink one, and then you can find the pattern. Try.
Is it 2004 choose 2 plus 2003 choose 2 all the way down to 1? Is that what it is? Hello?
Okay, again, can you say it? When you speak in for first time, I cannot hear anything. Can you say it again?
Is it 2004 choose 2 plus 2003 choose 2 all plus
Ah, exactly.
2001?
Yes, now your sound is great. 2004 choose 2 plus 2004 choose
2003,
2003 choose 2, right? The
yeah.
last one, what choose what?
Just 2 choose 2, I think.
Exactly. So sum of them. So have you calculated that sum and remainder when divided by 1000?
It's 2005 choose 3, which is
Yes. And calculate mod 1000.
5 times 3 times 60. 5010, so just 10.
So mod 1000 it is 10, right?
Yeah.
Okay, completely correct. Okay, so do you agree we solve this problem exactly with this idea KR and solving this inequality between 0 and 1, paying attention that R should be from 0 to 1, right?
Uh-huh.
Okay, so I just wanted to check this idea with you. And also as homework, let me tell you related to this problem you can solve what? We have some AMC problems similar to this. And also this problem, you can do this as homework. I researched to find AMC problem related to this. Okay. This one, let me answer this as page. Okay. Now for first part, for next part, I told you an idea in number theory uh, when we wanted to solve a problem of AIME.